Let's carry on and review Lean Six Sigma principles, definition of value, and we will also review an example of an oil change station where we'll identify value added versus non-value added activities and calculate waste ratio. When we say Lean Six Sigma, in fact we mean Lean and Six Sigma. Lean is a set of tools that aims to eliminate waste and maximize production flow, reduce cycle time. Six Sigma is about reducing variation and defects. Lean Six Sigma is a combination of all those tools and methods. Lean and Six Sigma complement each other and help us to improve the process. Do you remember 5 principles of Lean? They are defining customer value, focus on value stream, make value flow, let the customer pull, and pursuit of perfection. But what is value? Let's define the value. Value is a critical concept in Lean Six Sigma. It provides the foundation for continuous improvement and helps to determine which projects, products, services, and customer are worth pursuing. Value is a measure of worth of a product or service to the customer. Value-added processes is transformation of materials or information into products or services for which a customer is willing to pay. To measure the value, we can use 3 metrics: cost per unit, gross profit margin, or average sales, or the combination of all 3 measures. You can use these metrics to determine whether your company is creating products or services that customers find valuable enough to purchase at a certain price point. On the other hand, there is non-value added activities and process. Non-value added process takes time and resources, but the customer is not going to pay for it. Any time in the process where value is not added is waste, also known as non-value adding. Non-value added is any action that does not add value to a product or service, value being defined by the customer. It is the waste within the process. Therefore, during the process when an action is taken, it can be classified as value added or non-value added. Some of the non-value added processes are needed to run the business, and they are called business enabling activities. And it is our job to evaluate those processes and remove bad non-value added processes from the business model. So non-value added activities are waste. We will review types of waste later in the course.
See you again. Cheers. Anything else? Excuse me, madam. This might do the trick.
Oh.
At Caltex, our staff will do whatever they can
Thank you so much.
You're welcome.
to help make your life a little easier. Caltex. Nice and easy.
To help us memorize this, there's a 3C rule of value: customer, change, correct. First C, customer, product or service that the customer is going to pay for. Second C, change, the process or services that transforms materials or information to create product or service. And the third C, correct, each task is performed only one time and no correction is required. To understand the value add versus non-value add or waste better, let's consider an example. Imagine an oil change station. Process steps are recorded in the column tasks, and then there are time to complete the task and time to wait before the task begins. For the simplicity of analysis for this example, let's assume that our waste is wait time only. The total time is 31 minutes, and the wait time is 19 minutes. Having this data, we can calculate value added to non-value added ratio. The ratio is equal to time, 31 minutes, divided by time plus wait time, or 50 minutes. Therefore, our waste ratio is 0.62. In order to analyze production time, we also need to introduce a term of takt time. T takt time or takt, work time between two consecutive units. TA is the net time available to work during the period, for example, work time per period. And D is demand, customer demand during the period, for example, units required per period. Well, now let's illustrate this with an example. Let's say that the customer demands 1000 units per day. Factory works 2 shifts, each shift is 9 hours, and that includes 30 minutes break and 2 breaks of 15 minutes. So the total shift time is 9 times 2 or 18 hours. Total breaks and lunches is 1 times 2 or 2 hours. Therefore, net available time is 18 minus 2 or 16 hours. So 16 times 60 is equal to 960 minutes. Takt time would be 960 divided by 1000 or 0.96 minutes per part, or 60 times 0.96 equals to 57.6 seconds per part. This is a very simple example. In reality, you may need to subtract setup time, cleanup time, average daily downtime, changeover, unscheduled maintenance, and quality requests.